everyone, I am Joshita, pursuing third year in CSC department from Meenakshi Institute of Technology. As a part of Samsung Innovation Campus, I have built a capstone project. Let us imagine you went trucking and it suddenly rains as it causes a floods, or wildfire catches surrounded by you, or any earthquake happens surrounding by you, and you suddenly panic and you don't know how to get out of from that. And this made me to build my project Disaster AI. It helps you to find out which disaster it is, such as fire or earthquake or any floods, by just clicking a picture or by uploading an image. So we'll go through the project. So this is the exact pipeline how I built this project. First, I have imported a Kaggle Hub. Instead of manually downloading the dataset, I have gone through the Kaggle Hub and then I have downloaded the path. And as if I see here, I have two different folders as disaster dataset and earthquake. So first I thought to merge both a disaster dataset and earthquake dataset for easy processing. And here I have used Shuttle. It's in a library. It's used to copy or delete folders or files. And here I have merged all fire, flood, normal, earthquake. And then here I have counted the images. Here it is required because whether my to know whether my folders are empty or any corrected images are there. And then here I have also been noticed that my data is not balanced as earthquake images are very less as compared to remaining. Then here I have pre-processed my image and I have seen whether all images are opening and any duplicates are there, and I am removing all images which are truncated. And after that, here I'm using data augmentation as my data is not balanced, and that I'm applying my data augmentation only for the trained data. For the better training, it avoids overfitting. And here I have used pre-processing unit, and then here rotating image. These are all augmentation. And here I'm using batch size as image data generator helps for not loading all images at one go. It helps us to load the images into the memory as batches. And here I'm using the batch size as 32 and target size is 224,224 because I'm using a pre-trained model of Efficinet beat 0 as it is required a data image 224 cross 224. And here I'm using class model as categorical as I have my data set contains 4 different categories. So I have used categorical, and it uses one-hot encoding for multiple class evaluation. And there are many pre-trained models. Even I have used Efficinet B0 because it is very good for the dataset which is middle range and a small range dataset, and it is faster than remaining datasets, and it provides a balance between the accuracy and the speed, and it gives a less parameters as it does have 5.3 million parameters as compared to remaining pre-trained models. It does have small million parameters. And this is how it actually flows. This is the pipeline, how it works. And here it has been trained on ImageNet that it contains 1.2 million images, and that to have 1,000 parameters. So it is easy to find out edges or textures of image. And I have fine-tuned it and transformed it. For this, I have include top equals to false. What it does is it removes the classification layer at the last, and I have kept base model trainable as false because I don't want to train from the scratch. So I kept before layers, means before dense layer I have kept everything as it is, and from the dense layer I'll build my own model. Here it goes as a sequential, and layers dot I have used global average pooling and batch normalizing. It normalizes the output of before layers. And used an optimizer ADAM and learning rate as 0.01. Optimizer helps us to maintain a balance, and it helps us to learn from the weights and biases. And here I have kept loss as categorical cross entropy, as mine is multi-classable. And here I have using callbacks. Callbacks performs by itself during the training. Here I have used early stopping and reduce LR. Early stopping helps us when my model stops training. It stops my model, when my model stops increasing the validate accuracy, it stops my model training. And the patient's level is 5 and resource the best weights. And here I have used reduce LR. It's helpful for the learning rates. And checkpoints helps us to save the best model among the whole training data, and it monitors according to the validation accuracy, and it saves the best model. And here I have trained using a post 10, and I have used callbacks, early stopping, reduce LR, and checkpoint. This is my training. And here after I'm doing fine tuning. Except last 30 layers, everything will be freezed. From last 30 layers, I'm training my model again. And here again, I'm using optimizer, ADAM. And again, I'm fine tuning, history finding and all I'm doing. And here my model is getting trained. And this is how I actually use, this is all my layers. And I have saved my model. This is my model, I'll show you. This is about the system. It detects fire detection, flood detection, earthquake detection, and this provides AI assistant. And here image classification. It is predicting as confidence level 99.9%, and it's giving the probabilities like whether it's a flood, earthquake, fire, or normal. And this is the emergency precautions that we are supposed to take. Moving to the higher ground immediately or switch off the electric if safe. Do not walk through the floods. And here we have AI assistant. Here it given as based on analysis, this picture shows as a flood. The system is 99.99% certain that images contains high water covering the area. So this is how my project actually works. Thank you.